Now we're going to be working with distance problems. It's another application involving rational expressions. And with distance problems, what you want to remember, of course, is the formula for distance, which is distance equals rate times time. So let's look at this problem. We have two women, Renee and Sue. Renee can ride her bike 60 miles in 1 hour less time than it takes Sue to ride 60 miles. So they're hour faster than Sue's rate. Find Renee's rate. So with distance formula, what I like to do is, if you can, first of all, you need to write the formula down. Distance equals rate times time is a good thing. In this case, they're both starting at one point. Let's say this is Renee and this is Sue, and they're both riding the same distance. So the distance is the same in this case. It's going to be 60 miles. All right, the other thing that's very convenient with these problems is to do a table. Okay, so we're going to work with a table where we're going to give the information for each Renee and Ruth and Sue. Let me not change the people here. So we're going to put the information for distance under D, the information for rate under R, and the information for T for time will be under T. And let's let the second row stand for Sue. So in this case, we see that Renee can ride her bike 60 miles, so Renee's distance is 60 miles, and Sue is riding the same number of miles. Now, it says that Renee is going to be riding in 1 hour less time than it takes Sue. So we're comparing Renee's time to Sue's time, so that's a good thing to do, to start out with whatever it is we're comparing to. So let's say that T is Renee's time. If T hour less than that, and so that's going to be T minus 1. If it takes Sue 4 hours, it will take Renee 3 hours. Always check that, because it's easy to get confused here and to add or subtract in the wrong place. I think that it's a good thing to do with these problems is to do 2 columns of this table that I have right here, and then write the third column in terms of the other 2 using the formula that we have. In this case, distance equals rate times time. What we want to do is to solve for R, and therefore, if we solve this formula for R, we're going to have R is going to be equal to the distance divided by the time. So hours, Renee's rate is going to be her distance divided by her time. For Sue, it's going to be her distance divided by her time. So there we have the rate for each of the 2 women. And so for the, in order to have an equation, let's put the information over here. We have Renee's rate and Sue's rate, because that's the other thing that's given in the problem, a comparison between the 2. Renee's rate, according to what we have already, is 60 divided by T minus 1. Sue's rate is 60 divided by T. Now, in order to have the equation, let's go back and see what it is that we have not yet used. And we have that Renee's rate is 3 miles per hour faster than Sue's. Renee's rate were, for example, let's say 20 miles per hour. Then, since it's 3 miles per hour faster than Sue's, then Sue's rate would be 17 miles per hour. This isn't the answer to the problem, but it's just a little example just to show what we need to do with that 3. We know that in order to set the 2 equal to each other, all I would need to do is to add 3 to the 17, and I would have an equality, right? In other words, one way that I could do it is, this is the smaller number. If I add 3 to that, then I can say the 2 rates are equal. I could have done it is to take the 20 and subtract 3 from the larger one and set the 2 equal to each other as well. So, but this little technique that I used here of just putting in some numbers which might represent the problem helps a lot in seeing where it is that we need to add that 3. All right, so now we've got the problem, we have 60 over the little rational, an equation involving rational expressions, and we know that if we multiply by the lowest common denominator both sides of the equation, we will be able to eliminate denominator. So let's multiply the left-hand side by t times t minus 1, and let's multiply the right-hand side by t times t minus 1. On the left-hand side, the t minus 1 distribute will have 60 over t times t minus 1 plus 3 times t minus 1. Okay? So the 60 over t, the t's cancel off, and we end up with a plain to have our 60t. So now we have an equation that we can solve. It no longer has denominators, and so it will be a pretty straightforward problem. On the left, we have 60t, which equals 60 for this first term, plus 3t squared minus 3t for the second term. What we have is we can notice that I have a 60t on each side. If I subtract 60t from each side, those 60t's will be eliminated. On the left we'll have 0, on the right we'll have 3t squared minus 3t minus 60. That's a nice thing to do if you know that you have two terms that are similar on each side of the equation. Well, now what right-hand side over here, it's a quadratic equation, so all we need to do is factor the 3 from that. All right, we're still solving this. In order to solve this quadratic equation, we could see if this trinomial factors, and the negative sign says the signs will be different, and factors of 20, which give us a difference of t, are 5 and 4. So if we put a 5 here and a 4 here, then we're going to have this, which will be equal to 0. Now, if this is going to be involving t could be 0, so we could have t plus 4 equals 0, or t minus 5 equals 0. Okay? In this case, if we solve for negative, and so let's throw that out and keep the one solution that we have, which is that t is equal to 5. 5 hours. Now let's go back and see what the problem asked us to do. The problem said, so what we found is the time, so we need to do a little bit more work. And let's now go back to the table that we had earlier. So we now have that. All we need to do is to put the 5 into this part of the formula here and find Renee's rate. So Renee's rate is going to be 60 divided by 5 minus 1. That's the same thing as 60 divided by 4, which is 15 miles per hour. Okay? Let's check and see if those rates are this, differ by 3 by putting is going to be 60 divided by t, but that's the same thing as Sue's rate is 12